Okay, Year 8, we're up to our last video for this topic, and in this video we're going to learn about two-way tables. So this is what we've learnt so far. We've reviewed single event probability. Then we learnt about compound events and the language of probability, including and, or, not, at least, and at most. We learnt about mutually exclusive events and the probability laws, and then last video we learnt about Venn diagrams. A two-way table is just another way of organising two attributes. Like a Venn diagram, it's just a different method. Here's a two-way table here. This shows 15 males and 15 females and whether they're left-handed or right-handed. So you can see one attribute here is their handedness, are they right-handed or left-handed? And the other attribute is gender. Now each of these cells represent a different attribute, or pair of attributes actually. So there are 14 right-handed males. There's one left-handed male. There are 10 right-handed females and 5 left-handed females. And we can total the rows and the columns. And these two numbers here should add to the total number of people, which is 30, and so should these here. So just a different way of organising our information. Let's answer some questions about this. How many males are left-handed? So we just got to come up here. There's only one left-handed male. How many people are right-handed? So in this case, I want this entire row. There's 24. How many people are not left-handed females? Think about that for a minute. There's 5 left-handed females out of 30, so there must be 25 people who are not left-handed females. We can also answer probability questions from a two-way table. One person is chosen at random. Find the probability that they are left-handed. So we want all of these people here. There's a total of 6 out of 30, and we just write that as a fraction. Probability that they are right-handed and male. So here's the right-handed males. There's 14 of them out of 30. How about this one? The probability that they are right-handed or female. Now think about this carefully. These two are not mutually exclusive because there are 10 people who are both right-handed and female. So one way to do this question is to do the total number of right-handed people plus the total number of females and then take off the overlap, which gives you 29 out of 30. But if you think about it, there's only one person in this whole table that doesn't apply to this, and that's the left-handed male. So we could do the complementary event. Just do 1 take away 1 on 30, which gives us the same answer. We might have to construct a two-way table. Here's an example. A class of 25 students are going on vacation. 15 of the students are going to Vietnam, 18 students are going to China. Some are going to both countries. 5 students are not going to China or Vietnam. Construct a two-way table. All right, so drawn it up, got one attribute here, which is going to China, not going to China, and here's the other attribute, going to Vietnam, not going to Vietnam. And I've filled in the information that we have. We have a total of 25 students, 18 are going to China, 15 going to Vietnam, 5 going to neither country. Now, all you have to do with this is total the columns and the rows. So 15 plus something gives us 25. That's 10. 18 plus something gives us 25. That's 7. 5 plus 2 is equal to 7. And then taking the 2 from the 15 here, we get 13. And then finally 13 plus 5 gives us 18. And just a quick check, and that's correct. It's a little bit easier than doing a Venn diagram because it's straightforward. You don't have to do that, add it up and see how much you overlap. We can convert between Venn diagrams and two-way tables and vice versa. So let's have a look at how we take our two-way table and convert it into a Venn diagram. Let's draw it up to begin with. We've got our two attributes, Vietnam and China, and we know that they overlap. We've just got to put in these numbers. Okay, firstly we know that there are 5 students not going to Vietnam or China, so that goes outside. And then we need to know this overlap in here. How many students are going to both countries? 13. Okay, and we can easily fill in the rest of it. So going to China but not going to Vietnam is 5, so that goes in here. And going to Vietnam, but not going to China is 2. And so that goes in here. And there's our Venn diagram. All right, let's see if we can go the other way. Convert the Venn diagram to a two-way table. So this Venn diagram is about measles and chickenpox. So you can see here's my first attribute, chickenpox, not chickenpox. And here's the second one, measles, not measles. By the way, you can have these in the other order if you want. That's fine. Just like you can have these in the other order. Right, let's start with what we can see. 3 people have had measles and chickenpox, so that goes in here. 0 people have had neither disease, so that goes in here. All right, then we have got 15 people who've had measles but not chickenpox, so it just goes straight in there. How many people have had chickenpox but not measles? 12. And now all you have to do is add them up. So make sure that they tally. 15 plus 15 is 30, 18 and 12 is 30, but there it is, converting from a Venn diagram to a two-way table. All right, so that brings us to the end of this topic for Year 8. If you want to move forward in probability, you would be looking at a Year 9 topic called relative frequency.